Okay, this is the third video in our series looking at the binomial test in SPSS, and I've demonstrated how to carry out a basic binomial test going through the non-parametric test legacy dialog route, going to binomial and testing out a sample proportion against a hypothesized or expected proportion. What I want to do now is just show you a second route for testing, and that involves going through the analyze non-parametric test in one sample option. When you go to this option right here, you'll leave this button clicked, automatically compare observed data to hypothesized. You'll go to fields, and one of the things is that you'll need to select the variables that you want to include and leave them in the test fields and move everything else over. So I'm going to move all of these variables over to the original set of fields and leaving just this variable, ever try or use cigarettes. So I'm now going to click on settings, go to customize tests, and then click on compare observed binary probability to hypothesize. This is a binomial test. Under test options, you'll see that we already have a confidence interval set up at 95% and a significance level set at 0.05. So I'm actually going to click on options here, and what I'm going to be doing is just pivoting off of the previous example where I'm testing whether there's a significant difference between the observed proportion of adolescents in my sample who indicate having tried or used cigarettes before and a hypothesized proportion. And I'm actually going to stick with a hypothesized proportion of 0.40. So to utilize this test, and by the way, I'm going to test using a non-directional hypothesis. So to do this, I'm going to actually click on Klopper-Pearson exact for a confidence interval, and I'm going to form a confidence interval around my sample proportion, and then determine if the hypothesized proportion of 0.4 falls within that interval or outside. Down below, you can see it says define success for categorical fields. If I stick with use the first category found in the data, then the value that first appears for case 1 is going to be treated as the target category. So in this data set, I have my first category. It actually has a value of 1, which is the yes response to the question. But I don't necessarily have to rely on that particular option. You actually have a little bit more flexibility if you click on the select success values. Now I'm going to still select 1 right here because that's actually my target category, but I could also use 0 if I wanted to form an interval around the proportion observed in my sample who indicated not having had tried cigarettes before. So I'm going to stick with 1 though, which is referring to a yes response to the question, and I'll click on OK, and then click on Run. And so you'll notice that in terms of the output, the first thing you'll notice is that you get a hypothesis test summary, and this is actually going to be from a one-tailed test. But if I'm testing just whether there's a difference between my observed proportion and my sample proportion, and I want to essentially carry out what amounts to be a two-tailed test, I can click on this box right here, and where it says View, click on this button and then go down to Confidence Intervals Summary View. So click on that, and so now you'll see that the observed proportion in my sample data was 0.275. So that's the proportion of those with a response of 1, which is indicating a yes response to the question. The confidence interval ranges between 0.257 and 0.294. So the expected or hypothesized proportion was 0.40. So basically if you're testing a non-directional hypothesis, if the expected or the hypothesized proportion falls within the lower and upper bound, or between the lower and the upper bound, then you would actually fail to reject the null, or basically maintain the null, and conclude that there's no significant difference between the observed proportion and the expected or the hypothesized proportion. If this value falls outside of the interval, either on the lower end or the upper end, then you would reject the null hypothesis and conclude that the observed proportion and the expected proportion are significantly different. And that happens to be the case in this particular data set. So 0.40 falls outside of the bounds of 0.257 and 0.294, so we would reject the null hypothesis and infer that our sample proportion is significantly different from the expected or hypothesized proportion of 0.40.